Alright, in this lesson we will practice finding the least common multiple of two expressions. The concept of least common multiple comes up a lot when you think about adding fractions because you want the denominators to be the same in order to add the fractions, but you want the new denominator to be as small as possible, so we want the least common multiple. So the concept is you ask yourself, by multiplication, 4 can become 8 or 12 or 16. I'm doing 2 times 4, 3 times 4, 4 times 4. Using multiplication, 6 can become 12 or 18 or 24. So you want that the smallest number possible that you can turn both of these numbers into. Now, you can turn both of these into the same number by multiplying them by each other. A lot of people will do that and think, okay, let's make them both into 24s. All right, because 6 times 4 is 24. I can just make them both into 24s. But 24 is unnecessarily big. There's a smaller number that both 4 and 6 can become. If we multiply 4 by 3, that would make 12. If we multiply 6 by 2, that will make 12. So 12 is the smallest number that 4 and 6 can both become. 12 is the least common multiple. And of course, just to continue with this example, we would do the numerators too, and that would make 9 over 12 plus 10 over 12, and that would make, these would add together and make 19 over 12. Okay, but the concept that we're going to focus on is least common multiple. And in this case, if we look at 4 and we look at 6, the least common multiple is the 12 that we turn them both into. Alright, let me show you how prime factorization can help you find the least common multiple. Now, when numbers are small like this, it's easy to find the least common multiple in your head, because you can just look at this and go, oh, let's see, 2 times 4, 3 times 4, okay, that's 12. 2 times 6, that's 12. 12 and 12 is the least common multiple. But I want to teach you the skill of prime factorization for when it's not so obvious, when the numbers are not so small. So remember the factor tree. So the factor tree will help you find the prime factorization. 4 is 2 times 2, and so these are prime numbers already. So the prime factorization of 4 is simply 2 times 2. Let me show the prime factorization in blue. Okay, so the prime factorization of 4 is 2 times 2. Now, the factor tree for 6, it's 2 times 3. These are both prime numbers. So the prime factorization for 6 is 2 times 3. Now, if you look at the prime factorization, it's easier to see how to make both of these be the same. Okay? In fact, I see this 2 times 2. This is 2 squared. Okay, so we'll write the prime factorization this way. So I have 2 squared, and I have 2 times 3. Okay, so if you look at the prime factorization, if you want to make these the same, if you look at the 2's, you see this is 2 squared and this is just a 2. Alright, so if we want these to be the same, we'll make this a 2 squared as well. Then we look at the 3. This has a 3, this doesn't. So we'll have to give this one a 3. Now they're the same. So then you can look and see what we have. Well, 2 squared is 4 times 3 is 12. That's why the least common multiple is 12. Okay, let's look at one more example. Okay, say we want to find the least common multiple of 12 and 18. Alright, this would be a little bit harder to do in your head. You could do a couple of them, but it'll be a lot easier to use the prime factorization. So let's use our factor tree to find the prime factorization of 12 and 18. 12 is even, so I know that's 2 times 6. 2 is a prime number. 6 is not a prime number. This is 2 times 3. Both of these are prime numbers. Okay, I like to circle the prime number when I get to it. So the prime factorization is 2 squared times 3. So I've got 2 squared times 3. That's my prime factorization. Now for the 18 is even. That's 2 times 9. And then 9 is 3 times 3. Alright, so here's my prime factorization will be, alright, I've got 2 times 3 squared. Alright, so I want these to be the same. So what I can do is, first I look at the 2's. This has 2 squared, this only has 2. If I want these to be the same, I'll have to square this. So now they're both 2 squared. Now I look at the 3's. This is 3, but this is 3 squared. You can only make it more, not less. You know, you can't go, oh, how about we erase that 2? No, we're multiplying. So things will only get bigger, not smaller. So I can't erase the 2 to make them the same. But what I can do is square this 3. So now they're the same. Now I have 2 squared, and 3 squared, 3 squared. So this is going to be the least common multiple, so it's just a matter of what this is. Well, 2 squared is 4, 3 squared is 9. Okay, so 4 times 9 is 36. So the least common multiple is 36. Okay, now that's the background that you need in order to do this lesson. When the numbers are this small, you won't need prime factorization to find the least common multiple. You can just glance at it and know that the least common multiple is 30 by sort of starting with the bigger number and thinking about the multiples of this 10. Then you're thinking, okay, 10, the multiples are 10, 20, 30. And then, well, which of these can 3 become? Well, 30 is a multiple of 3, so that means 30 is going to be the least common multiple. Okay, so 30. Let's see. How about this one? Looking at the 15. The multiples of 15, 2 times 15 is 30. And right there, that's a multiple of 6. So 30 is the least common multiple right there. Okay, so again, the least common multiple is 30. Alright, now looking at 27, it's not easy for me to do the multiples of 27, like in my head. Let's go ahead and practice doing the prime factorization using the 27 and the 18. Okay, so the prime factorization of 27, alright, 27 is 3 times 9, alright, that's prime, and then 9 is 3 times 3. Okay, so the prime factorization of 27 is 3 to the third power. Okay, now let's look at the 18. I'll do it over here though. 18 is 2 times 9. Okay, and then 9 is 3 times 3. So the prime factorization for 18 is 2 times 3 squared. Alright, so let's just start with the smaller numbers. This has a 2, this one doesn't, so I'll give it a 2. Alright, now the 2's are the same. Now look at the 3's. This is 3 to the third power. This is only 3 squared. So I can only make more, not less. So I'm going to take this and make it into the third power. If I make this the third power, then they'll both be the same. So that's it. 3 to the third power is 27. So 2 times 27 is 54. So 54 is going to be the least common multiple. Okay. All right, and just to be clear, it makes sense because 54, all right, 54 is a multiple of 27 because 54 is 2 times 27, and 54 is a multiple of 18 because 54 is 3 times 18. Okay, so we're turning 27 and 18 both into 54. That's the least common multiple. All right, look at number 7. All right, let's stick to our strategy of using the prime factorization. So I've got my 24 and I've got my 32. Okay, 24 is 2 times 12, and this is 2 times 6, and this is 2 times 3. Okay, so the prime factorization is, I've got 3 2s, so that's 2 to the third power times 3. That's my prime factorization. And then how about the 32? 32 is 2 times 16, and this is 2 times 8, and this is 2 times 4, and this is 2 times 2. Okay, so 1, 2, 3, 4, 5. So that's just plain 2 to the 5th power. So this is my prime factorization. If I want to make these the same, well, this is 2 to the 5th power, this is 2 to the 3rd power. If I want these to be the same, I'm going to have to make this be the 5th power. Okay, and now I have them both as 2 to the 5th power. This has a 3, and this doesn't have any 3's. So if I want these to be the same, I'll have to give it a 3. So this will be the least common multiple, will be 2 to the 5th power times 3. Okay, 2 to the 5th power times 3. Okay, the least common multiple is 96. Okay, yeah, that's how you do that. So let's do it again. 24 and 36, prime factorization. All right, hold on, let me just do it separate again. So 24 and 36. All right, 24 is 2 times, well, you know what, if I've done it before. Okay, so we already did 24. The prime factorization was 2 to the 3rd power times 3. So I don't need to redo that over and over again. So 24, the prime factorization is 2 to the 3rd power times 3. Okay, now 36. 36 is 2 times 18, and 18 is 2 times 9, and 9 is 3 times 3. Okay, so the prime factorization is 2 squared times 3 squared. So 2 squared times 3 squared. Okay, that's from the 36. All right, now if I want these to be the same, all right, so I got the 2's. This is 2 to the 3rd power. This is only 2 squared. So if I want these to be the same, I'm going to have to make this be 2 to the 3rd power. All right, you can only make them more, not less. Here, looking at the 3's, this is 3 squared, this is only 3. So if I want them to be the same, I'm going to have to turn this into 3 squared. So the least common multiple will be 2 to the 3rd power times 3 squared. So that's 2 to the third power is 8. 3 squared is 9. So 8 times 9 is 72. So that's why the least common multiple will be 72. Okay, 72 is the least common multiple. How about number 11? Okay, prime factorization. So 18 and 15. Well, 18 is 2 times 9, and 9 is 3 times 3. Okay, so my prime factorization is 2 times 3 squared. And then I have the variable as well. So I've got my x, y squared. So that's my prime factorization right there. Now the 15, okay, I guess I'll do this in, no. Alright, so the 15, well 15 is 3 times 5. Okay, those are already prime numbers. So that's going to be 3 times 5, and then we have y to the third power. So we want to make both of these the same. So how are we going to do that? Well, this has a 2. This doesn't have any 2's. So to make it the same, I'm going to have to give this side a 2. Okay? Now the 3's. This is 3 squared. This is just plain 3. So to make them the same, I'll have to make this 3 squared. So we did the 2's and the 3's. We also have to deal with 5's. The purple side has a 5. The blue side doesn't have any 5's. So I need to squeeze in a 5 on the blue side. Alright, now we get to the variables. First, x. The blue side has an x. The purple side doesn't have any x's, so we need to give it an x. Now the y's. They both have y's, but the blue side has 2 y's. The purple side has 3 y's, so I need to give the blue side an extra y. So I'm going to turn this into y to the third power. Okay, now they are identical. 2, 3 squared, 5x, y to the third. 2, 3 squared, 5x, y to the third. That means I am looking at the least common multiple. So if I do 2 times 3 squared times 5, what do I get? Okay, so 2 times 3 squared times 5, that's 90. That means we're looking at 90 x y to the third power is the least common multiple. Alright, I think I'm going to stop this video here. Alright, I did the left column. We'll continue practicing least common multiple on the next video. So I will see you on the next video.